So muscle contraction, we said, is caused by, again, this input from the central nervous system. And we've gone over the steps of muscle contraction and how we fuel muscle contraction. I did want to mention real quickly the concept of muscle tone. Muscle tone is a concept that basically that muscles are always going to be under a small amount of tension. Now, that means that muscles, again, never fully relax. They're always maintaining some amount of tension. And this is from a number of reasons, most likely due to the fact that calcium is still kind of present within the fibers. And again, calcium is what's going to initiate myosin and actin kind of grabbing onto one another. And there also are central nervous system factors that result in muscle tone or potentially an increase in muscle tone. So again, if you're under a lot of stress, hopefully this course isn't stressing you out, but if you are, you get tight in your shoulder muscles or your traps and so on. That tightness is due to probably stress, which your central nervous system has then increased its input to these muscle fibers and therefore cause them to remain a little bit tighter under a little bit more tension than they normally would. The typical muscle tone for people is about 1% of their maximum force. So if you look at all the skeletal muscles in your body, they're always still somewhat active or tugging on one another, but or tugging on the bones they attach to, but only at about 1% of their true maximum. Again, I do want to talk real briefly about the muscle fiber types. We've talked about muscle fiber arrangements and muscle fibers. And again, we haven't talked at all about kind of how they're different. There are different types of fibers. It is a concept that's going to be really important, and we are going to discuss in this class, but it will come into play more in physiology of exercise. But muscle fibers, in skeletal muscle, there are 3 different types of muscle fibers. We call them type 1 and type 2, but then type 2 has 2 subclassifications. Type 1 fibers are also called slow twitch muscle fibers. You've probably heard this term before. They are called slow twitch because they are slower to contract. And the other big difference is they are fatigue resistant. So they are, while they may not be able to generate force as quickly, they will fatigue at a much slower rate. Type 2 fibers are called fast twitch fibers because they will respond to stimulus much more quickly and more forcefully, but then also they fatigue fairly quickly. Any skeletal muscle that we have actually includes both type 1 fibers and type 2 fibers. The exact breakdown, if we look at what percent is type 1 and type 2, depends on a lot of factors. It depends on the muscle that we're talking about. Again, some muscles are built more for speed, some more for power. But then also there are genetic factors. If your parents are both sprinters and very effective sprinters, they probably had a higher percentage of fast twitch fibers. That means you probably have a higher percentage of fast twitch fibers in general. So genetics and some training can also affect which ones develop more and therefore are going to be more effective and so on. But there are a lot of different factors that determine the breakdown of type 1 and type 2 fibers within a given muscle and in different people. Type 2 fibers are also subdivided into type 2X and type 2A. If you really are a muscle physiology geek, you'll find even further subclassifications if you want, and there's still some debate about these different classifications. But again, type 2X fibers are going to be the quickest contracting. They're the fastest contracting, but they're also the least fatigue resistant. So they're the ones that are going to wear out first, and then you'll have to rely on the other types of muscle fibers until type 2Xs are ready to go again. And then type 2A fibers are intermediate. They're sort of a little bit slow twitch, a little bit fast twitch. Type 1 fibers generate their maximum tension in about 1/10 of a second. Type 2 fibers do that almost twice as quick. They generate their maximum tension in 1/20th of a second in general. Individuals are thought to have a combination of these fiber types throughout their body and in their different muscles. And again, it varies a lot from individual to individual in terms of what percentage of fiber type they have in each muscle. Postural muscles, however, these are, again, the large muscles that hold you up against gravity. They're going to have a higher percentage of, again, slow twitch or type 1 fibers that are fatigue resistant because postural activities are lower strength, but longer duration. So we need fatigue resistant muscles here, or fibers here. And then phasic muscles, ones that we expect to contract very forcefully, but then they rest, are going to have a higher percentage of the type 2 and specifically type 2X. So the gastroc, it's a powerful muscle that we use for explosive type motions. It's a phasic muscle. That's what that means. They're going to have, the gastroc in general is going to have a higher percentage of type 2, specifically type 2X fibers. We've talked about how muscles work in a previous presentation, but again, make sure you're familiar with the terms agonist, antagonist, synergist, stabilizer, and so on, because muscles will perform all of these different roles when we move. And we'll be using these terms throughout the course. So muscles, when they contract, can do a number of things. They can act in a way to just maintain normal muscle tone, hold the body erect up against gravity and maintain posture, or they can produce forces that cause movement at specific joints or resist movement or forces from outside the body. So they can do a lot of different roles. We touched briefly on the different fiber types that are present in muscle tissue. I wish we had more time to go over it in more detail. You can look to one of my other courses that I teach, an exercise phys class, where we'll look much more in depth at fiber types and how we can train to target specific fiber types, and how fiber types are kind of found in different percentages in different muscles throughout the body. In the next couple presentations, what I want to talk about is force production, specifically the different biomechanical factors that affect force production, and how we can use exercise to enhance the body's ability to produce ever-increasing amounts of force.